that's what we're doing here. We're starting chapter 7. You lift up a little bit. Okay, you got it. That was my pen. So this is what I was thinking you would write for your definition. So it's a function f, and the function is a tricky fraction. It's a function over another function. So this whole chapter is fractions. Today's graphs aren't incredibly complex, but as we get through the chapter, we'll have like a full long expression over a full long expression. The most important part of the definition is this, that the q of x can't be 0. The reason q of x can't be 0 is because q is in the denominator. And we've talked about this before. Denominator can't be 0. And that little part of that definition is kind of what creates the whole graph. This is the graph we'll be making today. This is called a hyperbola. You can see that word there. Hyperbola. Hyperbola. It's a hyperbola. We call the blue curve and the break and the other blue curve, we call those branches. And what's interesting about this graph is that the points aren't as important as the asymptotes. So the reason that the arrow goes close to 0 but doesn't go through it here and here is because x can't be 0 because it would be undefined. So that undefined bit is kind of what guides the graph. That's pretty much it for your bell work answer. So we'll move on to your notes. Over, you go online and oh no. No, we're not. But if you want to do something online tomorrow, yeah. It's 663 and 663. No. If one of those numbers isn't on 663, I just assume you'll turn the page and you'll find it on the next one. So I don't know. You're too good with all of it. Just turn on the page. Yeah, you put the page back. If it's not there, then we go to flip another page. Oh. No. Yeah. Again, like, please. Okay, so here is the section if you want to rip it out. But again, you will have time at the end of class if you want to rip out the whole chapter and keep it with you. We are going to start. These are called. I didn't make up this word simple. I'm not calling them simple, but there's lots of different rational functions, and these are defined as simple because there's only one place where the variable goes in the denominator. We don't have x up top at all for this simple. But as we move through the chapter, some of our graphs are going to get kind of wild. So we got a regular plain old table here, -2 through 2. We're going to make this graph. The reason we're graphing this one is it's the parent function. So as usual, we'll graph this and we'll move it left, right, up, and down. Yeah, this one. And we'll move it all around. So I gotta plug in. So we got -1/2. We got -1. I got that. No, you didn't. How do you graph something that's undefined? You don't. See? You don't graph it. Actually, we will graph it as an asymptote.
Oh my god. So 1/0 isn't just 0? No. It's 1/0. What? It's undefined. Oh man. Yeah, no. Right.
Does anybody need to take this test today? Alright, draw your X and Y axis and plot these points. See what they look like. It's gonna look weird, like a pair of dice almost. Oh, no, not a pair of dice. One dice. It looks like one dice.
Or X. Yeah.
Maybe you see an X there. We'll make it ourselves. Just saw it in the book. So I actually start with the dash line. It's most important. So X can't be 0 here. And it's interesting because X will never be 0. When I look at this equation, it's pretty basic. If I put a 0 here, like not, since X can't be 0, it's also impossible to create Y as 0. So there's another asymptote here. Y is 0 is an asymptote. So -2, -1, 1, and 2, 1/2. So it's not a lot to go off of. If you don't understand asymptotes, you're likely to connect these points very wrong. So it's not the points that get the graph, but the asymptotes. So I put my pencil near a dash line because the definition of asymptote is that the graph gets very close to it at its ends. So I start with my pencil near the dash line. I move through the points, kind of smooth as possible, and then I come down and I end near the other dash line. And that's how the branches form. If we wanted to get more exact, we could put, -3, 3, and whatnot, but this is good enough because the asymptotes can really guide our pencil. So I start near a dash line, move through the points, and end near a dash line. I thought that that's that's not how dice work. Because they go like. I would never like look at that. Well, maybe your brain just doesn't go oblique like mine does. It doesn't go like a boomerang. You just gotta rotate that thing. No, it does. I see it more as a boomerang. Let's talk domain and range. So I could write the domain like this. It goes from -infinity, stops at 0, parentheses. If I put a bracket, that would mean I hit 0. I'm a comma it. It starts again at 0 and goes up to -infinity. So there's just a little break at 0. And for this one, the range is doing the same thing. it goes to 0, breaks, and then it starts back up again up to infinity. So that's the parent function. We're going to shift this left, right, up, and down. Oh, I should show you this. I'm not going to do this super precise, but I do want you to see if the 1 is negative, the reflection like kind of flips the branches. The branches, instead of starting low and ending high, like I kind of see these as a positive slope. The branches will go more like this. Go ahead, and then like a negative slope. So putting a negative anywhere in this fraction changes where those branches end up. What's that? So when I look at where the blue line exists, it's arrowing over here, so it's clearly over here forever. Getting close to 0, and it never actually becomes 0. But then it picks right back up on the other side of 0. And then it goes and goes forevermore. So the only place the blue arrow doesn't exist on the x-axis is right here at 0. So I'm moving from negative infinity to infinity with a break at 0. So you could just say that in words, or you can use the symbols. All right, so if we have to move this left, right, up, or down, here's our steps. Here's our transformations. If there's a number in the denominator with x, that's the h value. This was going to move the graph left or right. Since it's moving the graph left or right, the dashed line is up and down because it's a shift, like left or right, horizontal. If there's a number at the end that's in the k spot, that moves the graph up and down. So the asymptote is flat because it'll raise it or lower it, the horizontal asymptote. So the steps are a little bit different. Typically we start by plotting points, but with a rational graph, we actually start with the dashed lines. The asymptotes create the graph more than the points do. After you do the asymptotes, then you can do a table. Your table will look different every time according to h. The h that moves it left and right should be in the middle of the table. You want some points on the left side and some points on the right. And then you draw your hyperbola. So when you're ready, I am going to do this assignment. I'm going to do number 15 with you. And then I'm going to give you the rest of class to do all the rest. So when you're ready, you get to 663, and I'm going to start 15 with you. You ready for 15? Tons of people just Looking at their phones. Nothing better to do. Might as well just give my phone out. Give my phone out. Scroll through it. Those are not.
What'd you say? You have not?
What's 15? What's the equation?
Negative.
Oh, that's way more complicated than the one we just did. Can I scroll?
Yeah.
I don't think so. We're half and half right now.
Give Kayla a second to put it in the mouth.
We need to make like a shirt.
How's the mouth go? You like it? Honestly,
Why don't we just make it
we should make a
That's what I
shirt
just-
out with
that's
the whole
what I
time.
just said.
Math gallery. Look at her face. Why is she confused? Oh my god.
Taylor? Kayla? Yeah, Kayla did get a high test score.
Yeah, she has.
Was it over 100?
Yeah,
it was at 101.
Yeah, I got 101 to be exact.
Too smart.
You literally have.
after the
You
curve.
stopped
She's
cheating.
too good.
Yeah, what the heck, Kayla? Get out of here. Then your cousin is too good for you. Whoa. No, Kayla, stop. Stop talking. Don't play, Kayla. Kayla is annoying. I don't want Kayla.
Kayla Cummings is too good.
Bro, look at the game, Natalie. I see it. Right there.
Oh
boy. You just made it go away. You're so fake for that. Really just called her out. You have nothing to look forward to.
Okay, so I number 16 is gonna be tricky on that little tiny square. It kind of like freaks me out trying to fit that on there. So if you have a pen and paper, go ahead, or if you want to just do it on your notebook, paper, whatever.
You do?
Alright, so the first thing I see.
Get it. Where's yours? You don't have one. Because you handed it over, so I see. How do you rip it out?
Kayla, pass it to me.
I see that it can't be 4 because 4 would create a 0 down there, and that's a rule breaker. So that means we have an asymptote at x equals 4. And then I see this minus 1. That will be the other asymptote.
Stop saying her name like that. You're disrespecting.
At y equals -1.
What? Where'd that come from?
So when I
What?
see this, I'm picturing my hyperbola, it's going to be shifted right 4 and down 1. So if I gotta go to the right and down, I think I'm going to put my axis over here.
I think a while ago, but I couldn't say it.
Here's the dash. And here's the other dash. So step 1 is to draw the dashes, not to make a table, not to give points, to get those dashes in. The positive 4 and the negative 1. Now I will make a table.
You just write a straight line as long as it's white.
Yeah, it's not like law that it has to be dashed.
So for my table this time, 4 goes in the middle. That's the H value, creates the center. It's the asymptote.
So I'm not going to get a point out of there, but I know that's where my center should be. So I need 2 points to the left, so I'll do 3 and 2. And 2 points to the right, so I'll plug in 5 and 6. So I'll plug in 2 and get a number out, and then I'll give you guys some time to try plugging it in and getting the right value out. It's a lot of fractions, so I've always said if you need to go to a decimal to make precise graphs, that's okay. But sometimes looking at it in fraction form can be easier. -3 over 2 minus 4 minus 1. So 3 over 2, I mean, a lot of you guys are very good at looking at this as a mixed number. That's 1 1/2 minus 1. So that's a half. Or 1.5 minus -0.5. So my first ordered pair is at 2 1/2.
That's why I did that. Go back to your seat.
No, because then her hair will be in light.
You could have just told me that.
Oh.
David.
Riley, what do you get when you plug 3 in? I changed my mind. I'm sorry, Riley.
She changed her mind about that door.
It's getting real.
Oh, brother.
0. Hey, Natalie.
What?
Hi. You ever cut her off? Like hiking it out.
Okay.
-3 over -1 minus 1. 3 minus 1 is 2.
Did you get that one?
Confirm. And that's going to be 3, 2. I can see the dice forming.
Me too. I got an error for that one. Divided by 0 error.
Miss, that graph over there, do you see it with the,
I plugged in the
it's the
equation.
one farthest to the right?
Oh, it's because it's
Four?
undefined.
It looks
right?
like a
Yeah.
kite.
Don't talk to me, Halo.
Oh, yeah, kite. I don't think it would fly without those.
I got syntax error.
What if you did on the other side?
For which one are you?
5. Maybe I shouldn't have plugged in the whole thing.
Just careful with the minus sign and the negative sign.
How are we gonna,
Negative sign, minus sign, minus sign.
Oh.
That's what I think. It's my first guess.
Alright, that's fine. I got my answer.
Wait a minute.
wait a minute.
Uh-oh.
Miss Bowman, how are you gonna get -4 if it's with
Halo.
those lines?
Me too. Why do you have 1? You have 4. I'm on number 15. Why don't you work with the class?
You're at 54, no.
It's down here. I'm okay with that.
Okay.
5 negative 4.
It can be -4, it's not 4, right?
Right. No, but that's the x side you can't do 4. Y will never be -1. 6 negative 2.5. There they are.
Confirm.
Start with your pencil near dash line. Move through the points curved. And your dash.
Wait,
There it is.
Yay.
Think about end behavior. We'll talk about that more tomorrow.
Miss Bowman, I did it. Look at how pretty it is.
Very nice. What you will find is as that number up top gets bigger,
the distance the branches are from that center is bigger. So like that 10, you'll have a lot of space in the middle. Whereas if I had like a 0.1, like my branches would get like very close. So this is still like a stretch effect, the A value. All right, now go back and try.